about synthetic division. This is an amazing shortcut. It is such an amazing shortcut. I'm not even going to show you the regular cut for another like 2 weeks because this one is so much better. This is a way to do division of polynomials. So say we had 5x cubed minus 13x squared plus 10x minus 8, trying to divide it by x minus 2. One thing that's important is that this must be a linear binomial, which means the exponent here needs to be 1. If that was x squared, x cubed, we'd have problems. We wouldn't be able to use this method. But as long as that's a linear binomial, we're good. So here's how it works. The description is over there on the right. It sounds kind of weird. It looks weird when we do it, but trust me, you'll appreciate it once you learn the other way. So to do this division, what we're going to do is ignore the x's for just a moment. And we're just going to write the coefficients. I'm going to set up this little house here to put all my numbers in. I need to have space to have 2 rows here. The first row are going to be the coefficients of the dividend. That's this thing in here. That's the dividend. So 5x cubed. I'm only writing the coefficients. I'm ignoring the x's. Negative 13x squared, positive 10x, negative 8. I'm sorry, I don't need the x. I just said that. Negative 8. I do want to check just to make sure I didn't skip anything, any terms, meaning I didn't go from x cubed to x and skip over an x squared. X cubed, x squared, x to the first, no x's at all. Okay, we didn't skip any. We'll see an example next on the next slide where we do. Okay, that's step 1. Step 2, put the divisor on the right. So I'm going to take this x minus 2 and I'm going to put it over here, but the only thing I care about is that 2. And just like we've seen throughout the year so far, x minus 2, it's x minus the 2 is what I care about. It looks like I'm changing the sign from negative 2 to positive 2. Make sure you are careful about that. Okay. That's our setup. Then to do the actual division itself, I'm going to bring down the 5, and we'll see later on the reason why this happens is because the first division is 5x cubed divided by x, which is 5x squared, so that's why the 5 just comes right down. And then from then on, I'm going to be repeating this, multiply and add, multiply and add, multiply and add. I'm going to multiply the 2 times whatever number I just wrote down. 2 times 5 is 10. And then I'm going to add down the column. Negative 13 and 10 is negative 3. And then I'm going to repeat. Multiply. 2 times negative 3 is negative 6. And then add down the column. 10 and negative 6 is positive 4. Multiply. 2 times 4 is 8. And add negative 8 and 8, which is 0. I'm done. That's it. That's my answer. It's weird, it doesn't look like an answer. But what I have here, since I started with 5x cubed, and you don't need to write these down, I'm just showing you, 5x cubed, the answer is going to be 1 degree less than that, because what I did is I divided by x. X cubed divided by x is x squared. And just keeping that in mind, you can then kind of fill out the rest. If that's 5x squared, the next term is minus 3x, and then the next term after that is plus 4. That is your answer. That's it. You've done the division. It's weird because at no point did it feel like we were doing division, but that's what happened. There are 2 ways that this can get a little bit tricky. Actually 3, but we're only going to do 2 now. We'll save the 3rd for another time. So we can move this to later. And we're going to focus on the problem up here. Problem number 1. Same setup. The only catch is I am going to skip a term this time. Notice how I went from x cubed to x? When I set up my synthetic division, I just need to hold a spot for those x squareds. Everything gets a spot, even if I don't have anything to fill into it. 2x to the 4th, 5x cubed, 0x squared, because I need something to fill in that spot, 8x, negative 7. So again, this 0 came from the missing x squared term. And I'm dividing by x plus 3, which as far as we're concerned is x minus negative 3. And then we're going to do the multiply and add, multiply and add, multiply and add. Bring down the 2, 2 times negative 3. 5 and negative 6, and then negative 3 times negative 1. 0 plus 3, and then negative 3 times 3. 8 times negative 9, 8 plus negative 9, we're going to add, and then multiply, and then this time we have that number left over. Well, we're going to run into a problem with that number in just a second. Remember, this was x to the 4th. So when I do the little division, it's now going to be x cubed. So that's 2x cubed minus 1x squared plus 3x minus 1. And when I still have this minus 4, but I've got nothing to call. There are no terms left. Well, this negative 4 is what we call the remainder. And you might remember that word from when you were in like 4th or 5th grade. You might have learned that if you try and take 10 and divide by 3, well, it doesn't go in evenly, so you get 3 with a remainder of 1. You might have learned that word before. Eventually, you learned other ways to deal with that, like we would turn that into a fraction or a mixed number or a decimal, but originally used the word remainder. What we're going to do here is turn the remainder of negative 4 into a fraction. Essentially, we can do our division, but we have 4 left over, which we are still dividing by x plus 3. Just like 10 divided by 3 is the same thing as 3 with a leftover of 1 still divided by 3. So that's what we do with the remainder. The truth is, we're not going to have to deal with that very much this unit, because as you'll see in the next video, what we really care about are problems where the remainder is 0.